this we'll go only for the language fundamentals. So first, we need to understand what is software. Software is nothing but set of instructions, and we have understood the instruction part from the CPU. Because the job of the CPU is to execute the instructions that are there in RAM. So if RAM is having these number of instructions, obviously in terms of bytes and kilobytes, so the job of the CPU students is to execute those instructions that are there in a RAM. Yes. And what is a software then? So if you have a set, or if you have a collection of instructions which is performing some relevant task or some sequential task, then it will become what? A software. And it will become what? Software. Then what is a program? Program is to give instructions to computer. Without them, a computer can't perform any task because it doesn't understand a human language. Yes, so here is the CPU. So CPU, I told you, it can understand the language of a RAM, and RAM can store what, bachu? 0 1 and 0 1 only, bits and the bytes, and the bits and the bytes is nothing but 0 and 1. And if you like, you will call it a binaries. And further, if you like, you can call it a binary language also. So what I'm trying to say is that CPU can understand only a binary language. Binary language. That's what is the sole purpose, what I'm trying to say. And programs are created using programming languages that computer can understand. Yes, that computer can understand. So it's very difficult for us to remember these zeros and ones that I'm talking about. It's very difficult. For example, if I'm writing 0 0 1 0 0 0, and then I'm writing 0 1 0 0, and I'm speaking like anything, can you identify, can you decode it? Nobody can decode it because it's a hardware language, it's a binary language. We cannot decode it and we cannot understand. So these instructions, that they are written in binary code, which makes programming very slow and hard. What kind of a programming I'm talking about? I'm talking about a machine programming or a machine language, because they are the instructions which are built in. Okay, so I'm talking about what? A machine language. Okay, let me say it once again. Machine language, it's a binary code and it consists of what? 0 and 1. So for human, it is not possible. So after the machine language, which language came? It is the assembly language. And assembly language, it's just one-to-one, a conversion. For example, 0 0 1 is there. So for them, they have written one English word. For example, add. For 0 0 1 0 0, they have written another instruction which is subtract. So for humans, it is somehow possible to remember these add and subtract instructions, but still the assembly language is very, very low level language. And if you are converting a program from assembly language to a binary language so that the computer can run, basically you need one thing called assembler. One program is required which is called assembler. Yes, so that was the second language, but still there is a problem, because there is one-to-one conversion. So if, let's say, there are 1,000 instructions set in assembly language, so you have to remember the 1,000 corresponding English words for that. That was one of the challenge of assembly language. Further, it was very low level language, that computer programming becomes difficult in that. So what people have done in, they have developed some high level languages, and that high level languages are, similar to our mathematical equations. They are very close to human language, and it was started with many other languages also, but the most popular high level language that still exists, it is C. And then after that, C++ also came, and then Java, that is our part. And one more high level language that I would put it is a C#. So in this language, we are writing instructions so that every human can understand. And it's like, a mathematical equations or it is like a mathematical language. It is like a human language that human can understand and can interpret. For example, if you are trying to compute the area of a circle, it would be 4 into 4 if the radius is 4 into 3.1415. So now this is everybody can understand. Instead, if I write 001, somebody will not understand. Nobody will understand. If you write like this, then nobody will understand. But if you write add, and then if you write multiply, then very few people, there are just by the way people that they are coding in assembly language, especially those who are dealing with the hardware things, but it is difficult nowadays. What is happening is that okay, they are writing in C, then they are converting into assembly language. After that they are burning their code. I'm talking about the hardware systems, especially the embedded and the IoT part. So still they are doing in C and other high level languages, and after that they are converting into assembly language. What my point is, the computer languages, they are not started with Java, they are not started with a very high level language like Python, and now you have the AI kind of things. Here we write in English the instructions, behind the scene AI, your large language model, they can convert it into a code, even they can convert it into assembly code. Okay, so it is not started like this. It is started with zeros and ones, and you have to keep that this thing in your mind, that the journey was started from zero and ones, and all the way right now we are in the age we are using AI, and now with the help of AI we are writing a codes. Then popular high level languages, as I said, the most common is C, as I said. Then we have C++ also. Then we have Python also, and one more language because it's uh, very common in game programming, I would write C sharp. So these are the most common high level languages. And one language that I have missed is Java, and which is we are going to start. Yes, students, then uh, two things I'm going to cover and two things I'm going to continue in this. One is called interpreting language or interpreted language, and one thing is compiled language. So the heading is interpreting a source code and compiling a source code. Yes, program can be written in any high level language, but it needs a translator. Let me write it, translator. Okay, and to convert it into what? Either the output or to a machine code. So we need a translator, and there are two kinds of translator. One is interpreter and another is called compiler. And you need to understand these two terms very carefully. So when you are using the word interpreter, we call it interpreted language. If some language is using an interpreter, then we call it a interpreter or interpreted language. Or if some a language is using a compiler, we call those languages compiled languages. Let us try to understand and let us try to decode this mystery of interpreted and the compiled languages. Interpreter, as the name is suggesting, it is one by one students interpreting the instructions to the output directly. So for example, uh, one instruction is there, let's say S1, or one statement is there S1. So directly it will show the output for this instruction. And if S2 instructions is there, it will execute, it will translate, it will convert, and it will show the output. Yes, and if S3 is there, then it will show the output. When I'm saying output, I'm saying that it will translate, it will convert, and it will show the output one by one. It takes one statement and it gives the output. It takes second statement, it gives the output. It takes S3 and it will give the output. On the other hand, what about the compiled languages? Compiled languages, they are translated completely. So if three instructions are there or three statements are there, S1, S2, and S3 together, or collectively, they will be translated into either .exe, and with the .exe you can see the output. Let me give you the example. With the example you will understand. For example, JavaScript is one of the interpreted language. I don't know how many of you are using the JavaScript, but it is very important. It is not a Java. Okay, I'm not talking about Java. I'm talking about a JavaScript. Yes, students. So JavaScript students, it is what? Interpreted language. Yes, and interpreted language means what? Like I said, give one instruction, it will show the output. So if there are 10 instructions, let's say there are 10 instructions, so 10 printing statements I'm using, it will show the output 1, it will show the second output which is 2, it will show the third output which is 3, likewise 4. But here if you see that at line number or let me write it 5, so I will be able to count it 6. At 7th instruction, it is going to execute, no problem would be there in 7th instructions. But as soon as it comes to the 8th instruction, you will find there is an error. What is an error? Instead of write, I have written writes, just a spelling mistake is there. So it is already executed 7 statements. Now there is a problem. So the program will stop at this point, and after that all the instructions are not going to execute because problem or an error is coming at this point. And I have executed the same code, and because it's a HTML page, and in HTML page I have written this thing. So first thing is clear, second, third, fourth, fifth, sixth, seventh, up to 7th it has executed. And on just this 8th statement I have done one mistake, so I stop the execution. Let me give you one more example, and this example is of Python, because Python is also the interpreted language. So interpreted language works this way only. This is the first instruction, it will give the output. Second instruction, it will give the output. Likewise, the 7th instruction, it will give the output. Instead of this, here it is an error. It is an error. So already 7 statements are executed. Already 7 statements are executed, students. So they have printed, they have given the output. So we cannot roll back, and we cannot stop the previous execution. 7 statements are already executed, and half or more than half of the program is already executed. After that, these statements are not going to execute, because Python is also the interpreted language. On the other hand, this is the output that I have taken from the collab. I'll show you this in a demo also, so don't worry about that. At line number 8, here you see if line number 8, it is saying that there is a error and prints is not defined, but already 7 statements are executed. On the other hand, compiled languages, they are not working like this. First, what they will do, the whole instruction set, they will see, they will look, they will observe, like 4 instructions are there. So they will check every instruction if there is an error or if there is not error. If there is no error and all the instructions and all the statements are perfectly fine, then what the compiler will do, compiler will translate into a machine code. And the best example, bacho, is the example of what? I think I have missed. No, I have not missed. The best example is of C language, because the C language is compiled language. Yes, C language is what? Compiled language. So in this example, the same example I've taken, how many statements are there? If you can see, there are 10 statements, 1 2 3 4 5 6 7 8 9 10, but there is no error in this. If you see that on 8th instruction, there is no error. So this is going to compiled, and it is going to produce the result 1 2 3 4 5 6 7 8 9 and 10. And if there is an error on this point, so these number of instructions, they are not executed, because at compile time it will try to remove all the errors. That's the difference between a compiled language and interpreted language. Interpreted, one by one they are executing. Compiled, first they are translating into a low level language, and at the time of translation all the errors are being identified and are being they will ask you to the remove the errors. Even if you have a single error, they will not compile time only, and if any error is there, it will rectify at the compile time. Just to give you the demo of C language, uh, I'm using MinGV compiler, and all of you can use any compiler, maybe Turbo, maybe Borland, and maybe you can use Microsoft C and C++ compiler, but I'm using the most common compiler, which is MinGV, just to show you the demonstration. So here, this is my thing, and I have already made my program. Let me write it, my program, just to search for that. And if I open this program, students, you would see the code that I have written, and that the code that I have already shown. Yes, right now, I think it is not having any problem because it's a compiled language, but just I'm putting purposely one thing, which is prints, print f's. Okay, so I'm making a spelling mistake. Now I save this program and I try to compile it and I try to run this program. Let's see what is going to happen. Then I save this. To run this program, you guys should know that the compiler of C++ and C, because I'm running a C program, so you should know the C compiler. And the C compiler here I'm using is GCC, the most famous compiler of C. So let me write this way. I'm using a current directory, so I'll put it a dot and then I'll use a slash and then the command, which is GCC. Okay, and the name of my program is my program. And what is the extension? Let me write it correctly. What is the extension of C program? It is .c. Yes, and then I'm taking an output, which is this, and the actual output is my program.exe. My program.exe. So please note it down and carefully note down how to compile a C program from command prompt. I'm using a GCC compiler. For that, you can download the MinGV just to demonstrate this kind of thing. And then I'm using a current directory. This is dot and my program.c. Let me say if it is correct or not. And then the output I'm trying to produce in my program. Yes, program.exe. So what do you think? If I run this program, what is going to happen? Obviously, there is one error. Let me see. And the error is, all of you can see that printf's, and printf's function is not there, and it has not executed anything. 1 is not there, 2 is not there, 3 is not there, nothing is there. Just it is stopping you. Please rectify your error first, then you try to execute. Yes, so now what I will do is, again I'll go to my MinGV compiler, and here again I search for my program, and this is my program, and I'll open it. Please open it quickly for me. And where was the error? The error purposely I'm making on 8th step. So it is printf. Now I'll save this program. Again, I come to the command prompt, and then I'll write the same command once again. Current directory, the compiler name is GCC. Then the program name is my program. Extension is .c. I'm interested in the output, and the output is this, my .exe. Okay. Now, hopefully, at this point, it will run. It may show one, a warning, not the error. Let me see it, if it is showing or not. So it has, compiled the program, and it has produced the myprogram.exe also. It has produced myprogram.exe also, but it has shown just one warning: get ch. You should not use this function. There are other things also, because I'm using an old style of C programming, so I've used this get ch. How to see the output of that program? Just you need to write it again, a current directory, then this, and my program.exe. So all of you can see that the output is there, and the complete output is there on that screen. Yes, I hope interpreted languages and compiled languages are very clear at your end. Yes, similar exercise you can do for C++ also. Now, if For C++, you have to use this compiler G++. Okay, and your extension would be what? My program dot cpp. I don't have any program by this name, but you would do like this. G++ is the compiler name, and then the extension, instead of C, you would be using dot cpp. Similarly, you would show the output, and you would write like this: my program. Here the output is same, because we are computing the .exe. Now this .exe that you have produced, you can take anywhere. Yes, now I'll write my program, and you can copy this .exe and you can paste it anywhere. So I'm pasting right now here on my desktop. Okay, and I'm putting here. So if you click any time on this .exe, you would see the output. This is because this is executable file. This is just like, a calculator. So calculator is also an exe. You can find this, the path of this calculator. So if you execute this calculator, it will open up. So you made the first program in C, and the program is actually executable program, and the program is having an extension of .exe. This program you can carry to your computer, to any computer.